Hello everyone, I'm Mr. Ortega. Welcome to the channel. Get ready to discover the magic of physics and mathematics like never before. Let's begin.
Fractions and decimals are two different mathematical languages used to describe the exact same value, a number less than 1. This table uses a 100-square grid to show this connection perfectly. If you shade 35 squares out of 100, the grid visually represents the fraction 35 over 100, and it equally represents the decimal 0.35. The absolute easiest translation between these two languages happens when the fraction already has a denominator of 10, 100, or 1000, a number we call a power of 10. To convert this, you just count the 0 in the denominator. Here, there is 1. Then you take your numerator and shift the invisible decimal point one space to the left, giving you 0.2. Fractions with a base 10 denominator require zero actual calculation. You are simply repositioning a decimal point to rewrite the exact same value in a new format. Of course, most fractions don't start with a convenient 10 or 100 at the bottom, but many can be scaled up to get there. Take 1/5. Instead of doing complicated division, we can multiply it by a fraction that forces the denominator to become 10, in this case 2 over 2. Because 2 divided by 2 equals 1, multiplying by it doesn't change our original value. We multiply straight across. 1 times 2 is 2, 5 times 2 is 10, which equals 2/10. Now we have a base 10 denominator, so we apply our rule. We shift the decimal point one spot to the left, and we get 0.2. Look at the fractions in exercise 7 of this worksheet. Let's try scaling up 4/5. To convert this quickly, ask yourself, how can you scale that 5 up to reach 100? We know 5 times 20 is 100, so we multiply both the top and bottom by 20. 4 times 20 is 80, giving us 80 over 100. That shifts straight into 0.80. Searching for a multiplier is a highly efficient shortcut. It bypasses complex long division entirely and lets you rely on the simple decimal shift. Eventually, you will encounter a fraction like 5/8. 8 doesn't neatly multiply into 10 or 100. When scaling up fails, we use the literal definition of a fraction. The fraction bar is actually a division symbol. The most common mistake here is putting the larger number inside. You are dividing 5 by 8, so the top number goes inside the bracket and the bottom number goes outside. Since 8 doesn't go into 5, we add a decimal point and placeholder zeros to the number inside the house to keep the division going. Working through the math, 8 goes into 50 6 times, leaving 2. Bring down a 0 to make it 20. 8 goes into 20 twice, leaving 4. Bring down the final 0, and 8 goes into 40 exactly 5 times. Our result is 0.625. It takes more mechanical calculation, but standard long division is your failsafe. It works for every single fraction in mathematics. Sometimes the division process simply refuses to end. Let's try converting 1/3. 3 goes into 10 3 times, which leaves a remainder of 1. Bring down a 0, and you have 10 again. 3 goes into 10 3 times, leaving a remainder of 1. This creates an infinite loop, repeating forever. As this text explains, a result with an infinitely repeating pattern is called a periodic or repeating decimal. To properly notate this and stop calculating, we use a specific symbol. Instead of writing an endless string of 3s, we write the repeating digit once and draw a straight horizontal bar directly over it to signify that it continues infinitely. Looking at this reference table of common fractions and their decimal equivalents, you can spot all three methods at work: base 10 shifts, multiplied equivalents, and long division results like the repeating 3. Mastering these three conversion paths gives you a complete mathematical toolkit. You can inspect any fraction and immediately choose the most efficient way to translate it into a decimal.